Hello everyone, so today I'm going to go build an amplifier, but this time it's only going to be a baby one, so it should be quite trivial for us to build. Now, I like MOSFETs, so I'm going to be using MOSFETs. There are other options, but you know, this is so cheap and so easy that this is probably the way to go for like QRP amps. Alrighty, I do want to show you how the MOSFET works. So I do have a multimeter and diode mode. Now, for reference, the multimeter in diode mode puts out a little tiny bit of voltage. So you can see, hang on, puts out 3.3 volts. So we're going to only be able to measure threshold voltages up to 3.3 volts, but that is okay for these two MOSFETs here. All right, so the way to check a MOSFET, if it's working or not, you want gate, drain, source, at least on these two. That's the way they are. So we want to put our negative terminal on the source, like that. I need to not touch the tab there. And I'm going to touch the gate with positive, and you should see nothing. Touch the drain, it should be short-circuited. Then if you touch both of them together, the gate and the drain, it'll find the voltage of which the MOSFET just turns on, and that's 2.19 volts. And to double check that it's really a good MOSFET, it's still 2.19 even with nothing on the gate, because the gate is still a capacitor, very high impedance. To show you that, actually, if I try and hold this on the the drain terminal there. Oh, I shorted it together. There you go. Nope, still short. Oh, hang on. There you go. All right. If I hang on, I'm going to put it over here because this is also drain actually. If I just touch the gate, there you go. MOSFET turns off. MOSFET on. Just touch the gate because my finger's on the negative lead, not the positive. So my finger is negative. Just touch the gate. Dunk. It's off because I sucked all the charges away. But anyway, that's the kind of the 3 points of the MOSFET. You have off, like hard off would be reverse biasing the MOSFET here. And then we'll check it again. So you got negative there on the source, and then drain terminal, it's off. We put all the charge into the gate and do that again to the drain. You should see a short circuit. And then again, if we do the same thing with the shorting the drain and the gate together, so that way the gate voltage will be the same as the drain voltage. The drain will pull it away, obviously, when the MOSFET starts turning on, and you'll start getting the threshold voltage. I'll show you that with this other MOSFET too. So this is an IRF510 that's been pre-loved, as you can see by the short leads, and that one still works. I probably blew up the other pair or something when I removed that. Do the same thing on this one. So gate should be on. Yep. And actually just kind of turn it off with my finger because that's kind of fun. Sorry, put that there, and I'll just touch the gate. Actually, I think I should be able to turn it on if I... Okay, maybe not. There you go. MOSFET on, and I'll suck all the charges away with my fingy. There you go. So that's how a MOSFET works. It has a control voltage, and it's basically a current... Oh, sorry, a voltage-controlled current, constant current source. So, yeah, I guess I'll show you the MOSFETs I actually want to use, though, and I'm going to show you a problem with them. So we're going to get our... There's a reason why I buy so many, and you will want to as well. A, they're cheap, so if you blow them up, it doesn't really matter. But B, let's see if I can grab a few out, because hopefully I can see the difference. The Z24N's have just a slightly higher threshold voltage that my multimeter cannot read. So, hang on. Oh, I've shorted to the drain there. So no, can't read it. Sometimes you'll get lucky, you'll have one that's like low enough, but honestly, these are all kind of too high for me to read. So there is a trick I use to try and identify these, and I need a matching pair as well. So I'm going to show you the trick for the matching pair. All right, I have a device. This. This is dodgy. This is very dodgy. This is 12 volts. This is a I think it's a 100 ohm resistor. So this gets scorching hot if you leave it in there too long. And this here is just so I can attach my multimeter probes. So it does the same thing with the terrible soldering there. It shorts the gate and the drain together, so I can measure the voltage there. And this gives me kind of a higher voltage to work with. All right, I'm going to go set that test up, and I'll test a few of these MOSFETs until I find one that matches with another one, because that is actually important. All right, be right back. All right, we'll do a little quick test here, and actually we're going to see something wrong. And I'm not entirely sure why, but I think I've already hit oscillation, and it's kind of interesting with this setup because this is all DC. All right, so what I'm going to do is I'm going to turn this power supply on. We're going to see the bias voltage here, and it's going to use the power from this little power supply here. It's pretty dangerous, so, you know, don't buy one of these, I think, but we'll give it a go. So we'll turn our output on. Now, what's going to happen is we're going to lift up our bias voltage here, and our current's going to be shown here. So in theory, when we hit our, was it 3.9 volts, we'll start seeing this current rise. So let's see what happens. Now, we'll get my hand out of the way there. And as you can see, that is not what we see. Especially because there's no correlation with the output of the the output of the supply to the MOSFET. This here is almost certainly an oscillation, and I kind of find that wild. So I'm going to take this lead off, and the voltage went away. So I think I've already hit oscillation, which is extremely interesting for this setup because it's all DC. What I'm going to do is I'm going to take the silly way to deal with oscillation. I'm just going to put a resistor in series with the gate here. So yeah, that will almost certainly fix it. I didn't expect to hit it this early. I wanted to show you oscillation later, but such is life with MOSFETs, I suppose. They don't always behave how you want them to. All right, I'll set that up and then I'll be back. Actually, I kind of changed my mind. I might just try and use a little bypass capacitor. So these are little disc ceramics, only good for like 50 volts or something. But if well, obviously the VNA is in the open circuit position here. This is kind of like your ohm meter range along that center line there. So if I put a resistor in there, you'll see that by 7 megahertz, she's almost a dead short. So I'm not sure where this was oscillating, but I don't really care. This here will short out any oscillation, hopefully. So we will give that a go. All right, I'll chuck that in and see if it stops. All right, buddy, time for round 2. All right, hopefully this works with the little bypass. I still may need the series resistor so that it has a high impedance on this side and a low impedance on that side, but we will try. All right, let's see what we see now. Here we go. See this? Oh, nope. She's still doing it. Okay. That was better, but no. No. All right, I do need the series resistance as well. Okay, I wanted to avoid that until later, but it is what it is. All right, time for round 3. So I put a 4.7k ohm resistor in there, so we should have 4.7k on this side and nothing on this side. So hopefully this doesn't act like an antenna and pick stuff up, and hopefully we've got it under control because this should be fairly stable now. Hopefully, fingers crossed there. All right. Let's plug her in to the supply. Good, we don't see anything. Turn our output on. All right, let's try this again. So we're looking at this one. So it should start to just read a few milliamps somewhere, and that'll be our threshold voltage. I think we discovered it was like 3.8 volts or something at 100 milliamps, but it will turn on a little bit lower than that. All right. Go look. There we go. So we're pretty close. Alright, should be able to use the fine control now. So at 1 milliamp, we're at 3.25 volts. Go up to 3.4, see what we see. I'll do 100 millivolt increments now, so we're at 5 milliamps. So go up to 3.5. Oh, too far. Come back down. We're at 12 milliamps, so 3.6. The bottom end of this MOSFET curve will be very not linear, but eventually you'll get up to the point where it'll start acting normally. So 3.6, 26 milliamps. And I'm out of fine control there, so we'll go, whoa, hang on, that's a little bit too much, don't you think? Hang on, we'll go back up to, sorry, I got my hand in the way there. Put that all the way down the bottom and then go up to like 3.5, there you go, something like that. So we'll do 100 millivolt increments and see how far we get. 3.6 would be, come on, 28 milliamps, 3.7. Wow, the control on this power supply is really, really sensitive. Whatever, 65 milliamps. I'm not going to be that accurate. 100 milliamps. 3.9 is 200 milliamps. 4 volts is 450 milliamps, and it's going to start to warm up now. 4.1 is an amp, so we got about 12 watts there. 4.2. We'll go up to about 4.2 is almost 2 amps, but that's getting hot now. So I bring the bias right down, you'll see it'll start cooling off and the current will come back down. So MOSFETs are a little bit temperature sensitive with their current draw, but you can see now that basically a voltage here correlates to a current through drain source. So this is working completely correctly and how it's supposed to. Try and measure the transconductance for a second. Give me a second. So I'm going to go to 3.9 volts. We're at 200 milliamps. I'll turn it off for a second. 3.9 volts is, what do we say? 200 milliamps for 3.9 volts. I'm going to bring this up to 4 volts on the display here. 300 milliamps. All right. That's 300, wasn't it? Yep, 300-ish milliamps. I'm going to go 4.1 volts on the display. I'll turn that on for a second. So at 500 milliamps. So for every 100 millivolts, we're getting, you know, what's that? Is it 200 milliamps of current? We'll go 4.2 volts. The curve here will increase, but it'll kind of steady down to a stable value. So we'll turn this up and get 4.2 volts. 800, but it gets pretty warm pretty quickly because this is a tiny MOSFET. So we're seeing about, what was that, 400 millivolts increase over 100 millivolts? Oh, 400 milliamps increase over 100 millivolts. So that's about a gain of 4. I don't actually know what the data sheet says, so we'll go back to 4.1, see what we see. 500 milliamps-ish. And go 4.2. 800 milliamps. We'll go 4.3 as well, just for a second here. 1.3 amps. So for every 100 millivolts, we're getting, well, I don't know, like 400 milliamps, something like that. So that's a gain of about 3. So that's not too bad. 3 amps a volt, I should say. So this is how MOSFET works. So that's the amplification bit we're doing. We're using a little tiny bit of voltage control to control this current here. And these are good for, I think, 17 amps. But I can tell you this heatsink's not good for 17 amps. I'm gonna go up to 4.4 just out of curiosity. We will go to 4.5 as well. See what we hit. 4.4 volts is 1.9 amps. Turn it off. Go to 4.5. 2.5 amps-ish, I saw there at the start. Go 4.6 volts. 3.1 amps, I think I saw at the start. So you get the idea. More voltage on the gate means more current through the MOSFET. Okay, so that's the MOSFET. Now we're going to go move over to the input network for this, so we can actually drive this terminal here. I was hoping to bring in these little components later. I thought, you know, if I just put that there on the gate, like I did with the my little 48 volt amplifier. Well, actually, no, I didn't. I actually put it pretty much where it is right now. I'm just kind of surprised that it started oscillating without any external help. There's no RF bits around here. It's just all long leads. So I'm almost tempted to figure out where that oscillated, but I don't really care too much. It's just something you do have to watch out for these MOSFETs. All right, maybe I might call this video 1, and then I'll move over to the input network where we're going to build the input and probably the output on this board as well, actually. So yeah. All right, this will be video 1. I'll catch you in the next one. 73 VK4 Delta Lima.